Okay, my molecule is FCCF, and my name is Maximilian. Okay, so my molecule is FCCF, and as you can see, there is one single bond between the F and the C and the F on the outside, but there is a triple bond in between, which makes this molecule linear, and that is a whole 180 degrees. So the Vespert diagram in completion will look just like the Lewis structure. Let me just draw the electrons on the outside. And I stated earlier, the outside bonds are single bonds, which are sigma bonds, which contain one sigma bond in each end. Now when there's a triple bond, one of those bonds is also a sigma bond, but the other two that are contained right there are actually two pi bonds. And we'll explain that in further detail in the next slide. So now I'm gonna draw the box diagram. We're gonna start off with the ground state for carbon, and that's gonna be starting off right here. Let me just label that ground. And we'll just start off with drawing electrons that might bond, so we'll disregard the 1s box. Starting off with 2s right here, and then the 2p orbital. So we know that carbon has 4 valence electrons, which will be accounted for right here. Okay, so in this slide, I'm gonna show you the box diagram. Just label that up here. So carbon in its ground state normally has 4 valence electrons. So we're gonna skip 1s and go to the electrons that might bond. And that is gonna fill here, the 2s orbital, and fill only 2 slots of the 2p orbital. So you can see that is already a problem. So in order to fix this issue, we're going to promote 1 electron from the 2s orbital and bring it in to the 2p orbital on top. And in this state, the carbon is in an excited state. So now that we have promoted 1 electron to the 2p orbital, every slot has been filled. And now we have 4 unshared electrons that can possibly share with a C, with a carbon, or an F of fluorine. So when we hybridize this to be able to share them, it's actually getting a little complicated because the pi bonds that we saw earlier between the C do not hybridize, so they can only be bonded in 2p orbitals. So now, when we want to hybridize this and share those electrons, turns out that this next orbital, is actually sp. And this is in the bonding state of carbon. So this sp orbital contains two slots, actually, where the electrons of the carbons are going to actually bond with the electrons of the fluorine atom. And I'm going to show that here because, as we all know, fluorine has 7 valence electrons, so it just needs that one more that it's getting from the carbon. And that's going to be, I'm going to show a visual representation of that in the next slide. So these are bonding with the fluorine atoms. But like I said earlier, the 2p orbitals are going to be for these leftover pi bonds that cannot hybridize. So what did hybridize? Let me just represent that here. Was the sp orbital. And when we actually promote it up here, I'm going to fill that in. It used up a bit of energy as well. So as I was saying, the 2 pi bonds are actually going to go up here, and these are actually going to bond with the carbon itself, as we saw earlier with the triple bond. Let me disregard this state right here. So there's 2 pi bonds bonding with carbons on the top, and the 2 sp orbitals, which are bonding carbons with the fluorine atoms down here. And the next slide, I'm going to show you a visual representation of all of this to make it a little clearer. In this slide, I'm going to draw the contoured diagram. So I'm just going to label that up here. Contour diagram. So, to begin, we know that the triple bond between the 2 carbon atoms contained 2 pi bonds and 1 sigma bond. So that sigma bond is still going to be counted right here in the overlap of these 2 sp bonds. That's the sigma bond from the triple bond. And I'm just going to write the sigma bonds for now, and then we're going to do the pi bonds. So from the carbon and the fluorine, there was also a sigma bond coming out again on this side. And then the fluorine's 2p orbital, which was the one empty valence electron that could bond, it's now going to bond with this sp one, and it's going to overlap as well. So this comes from the 2p orbital for fluorine, and this is coming from the specialized hybridized sp orbital. So you can see it there. And of course, this is all one big 2p orbital. Let me just finish that here. And the same is going to actually happen on this other side for the carbon and the fluorine. So that's going to be, forgive the shapes. The pen is hard to maneuver. And this is going to connect with the 2p orbital right here. So these are all the sigma bonds as mentioned earlier. We have a sigma bond there, a sigma bond there, and a sigma bond there. 3 sigma bonds in total. And now what we're going to represent are the pi bonds, which are bonding in between the 2 carbon atoms. So I'm going to draw one pi orbital right there. I'm going to color it so it can be distinguished between the others. And then I'm going to draw another one here. On this side, that's the second one. And the same is happening with the other carbon, because these are actually going to bond with each other. So now, these pi bonds are going to bond with each other. I'll indicate here and here. And the same will go here and here. And those are the two pi bonds which will be bonding to each other. Okay, so that is the full contour diagram for the FCCF molecule. Thanks for watching. Again, my name is Max.